So the first term was a lot of prerequisite stuff. So what does the negative exponent mean here? Go to the bottom. Now, is this negative part included in the exponent? No. So it's negative 1 over 5 squared, or negative 1/25. What would it have had to have said for it to have been positive 1/25? Or would have had to have been around the negative 5? If you had negative 5 in parentheses to the negative 2, then that's the same thing as 1 over negative 5, the whole thing squared. If it's not in parentheses, it's not included. How do you work out numbers raised to rational powers? Which part's the root? The 3 is, the denominator is. So it's the cube root of 27. Take one of each. One says notes, one says homework. Okay. And so then you cube root 3, or cube root 27, which gives you 3, and 3 squared is 9. Technically, you could also square first and then cube root, but do you want to square 27? Oh, God, no, right? No, it's terrible. Don't do that. Okay. And then, holy moly, simplify me. So the first thing that I would think is that work inside those parentheses first and simplify as much as you can. So move all of the negative exponents from where they are. Does that make sense? To the opposite place. Can you do 6 divided by 3? Yeah, so you get 2. You're going to have m and m in the numerator, and n squared in the denominator. Does that make sense what happened there? So this n squared goes down, right? And this m to the negative 1 goes up. Okay. So that's the same thing as 2m squared over n to the 4th, all that to the negative 3rd power. Okay, now what next? What does the negative 3 do? It's actually going to flip it. Does that make sense? The same as this n to the negative 2 reciprocated that. This will reciprocate this thing and make it n to the 4th over 2m squared, all to the 3rd. And then what happens to the powers? They multiply, so that's n to the 12th over 8 or 6? 8. Why is it 8? It's actually 2 to the 3rd, right? Not 2 times 3. So 2 is a regular number. It's being exponentiated. And then m to the 6th. Do you remember that? Okay, hopefully. All right, so rationalize the denominator. This idea comes up in calculus, although you have variables and not numbers when you do it. So what do you multiply to rationalize the denominator? 3 plus root 5. And whatever you do to the denominator, you also do to the numerator to be fair. That effectively, what you're doing is multiplying by 1, and multiplying by 1 doesn't change anything, right? It's multiplying by 1 in a clever way. It's a clever version of 1. So that gives you 3 plus root 5 plus 3 root 5. What's root 5 times root 5? 5. From the numerator. And the denominator, you get 9 plus 3 root 5 minus 3 root 5 minus 5. If you chose correctly, what should happen in the denominator? The roots should go away, and if they don't go away, you'll know you picked the wrong sign in the middle. So what does the numerator, there are some like terms there, what combines? 3 and 5, that makes 8, and then how many root 5s are there? 4. and all of that's over 4. You can divide by 4 and you get 2 plus root 5. The way you use that in calculus, there's just going to be x's and things inside of that root, but the idea of what the conjugate is the same. So, and how you rationalize. All right, this was actually a calculus question in disguise. If you'd taken calculus, you would know that, which you don't have to have done that, but you'll see stuff like this all the time. So this is just do huge amounts of expansion. So when you do x plus h squared, that's x plus h times x plus h minus 3x minus 3h, because that negative 3 distributes. What happens when that negative, this negative distributes into that set of parentheses? Negative 2x squared plus 3x. Spectacular. It is pretty useful to know what x plus h squared is really quickly. What is it? Great. And the 3x's cancel, don't they? So we have minus 3h minus 2x squared. And then distribute your 2, and you got 2x squared plus 4xh plus 2h squared minus 3h minus 2x squared. Does anything else cancel? And you're left with 4xh plus 2h squared minus 3h. And that's kind of a component of a problem that you would do in the calc class, pretty early on, actually. Oh, you could, yes, you definitely could. You could factor out the h, like it's the greatest common factor. And I would neither require you to do that, nor would I dock you if you did. Does that make sense? So like if you do extra work, it's fine. It's a bit of it's a contextual thing. In a calculus class, that h would be, there'd be an h in a denominator and be canceling, so don't worry about it. All right, ooh, factoring comes up all the time in calculus, so you have to be pretty good at it. So with this one, what's the first thing that you should do? Take out the greatest common factor, yep, which is 3y. You're left with y squared minus 5y plus 6. And a lot of factoring that you see is like that y squared minus 5y plus 6, where you have a leading coefficient of 1. So how does that factor? The numbers you're looking for have to multiply to make this 6 and add to that negative 5. And they are negative 2 and negative 3. Why doesn't the combination of numbers negative 6 and positive 1 work? Why is that wrong? Do they add to negative 5? Do they multiply to make positive 6? No, that's the thing that breaks, right? Okay, so there it is, completely factored. If you're taking your final and you got spare time, you can check it by remultiplying it out, right? You just take some scratch paper and give it a check. Okay, this one was the one you hated. This had a formula. There was this a cubed plus b cubed and a cubed minus b cubed formula. Does that ring a bell? So this factors into a plus b, a squared minus ab plus b squared. And the second one is almost the same. It's a minus b, a squared plus ab plus b squared. And the acronym that I've seen used is SOAP for same, opposite, always, positive. Do you know what that's referring to? It's the signs. So it is definitely a really tricky factor pattern. It is totally not obvious that when you multiply these things together, that stuff's going to cancel. Like you can prove it to yourself by just multiplying that stuff out. It's just tricky. So what number, in this case, so you know to use it when you've got two things added and there's cubes. Okay, that's the hint. And what you plug in for a is the cube root of that first thing. So what is the cube root of 8x cubed? 2x. And b is the cube root of 27, or it's 3. And this a and b are always chosen to be positive numbers. If you have a minus sign in the middle, it just means use that second formula. You could technically pick b to be a negative number and then plug in a negative b and use the first formula. That would work. So that factors into, okay, so a plus b, so 2x plus 3 times, so what do you get when you square a? 4x squared minus a times b, so minus, and then plus b squared, which is 9. And this second polynomial is pretty much always going to be prime. I think the best that can happen is it can have a greatest common factor. If it factored more, this formula would factor more. Does that make sense? Okay. That one's specific enough, I bet you had forgotten it. All right. And then this stuff. So multiplying and dividing. Okay, there's a smart way and there's the not smart way. Do you want to just go nuts and distribute?
No.
Gosh, no. You want to factor first. Factor and cancel like factors. It's kind of like doing 121 over 3 times 2 over 121, right? You would want to cancel those 121s first, right? So factor like crazy. How does the first thing factor? X minus 2, x minus 3. The reason that x minus 6 and x minus 1 does, you said minus or plus?
I said minus 6 plus 1.
That doesn't work. There's a really specific reason. So the numbers that you're looking for have to add to negative 5, right?
We don't multiply.
Great. How does the x squared minus 4 factor?
X plus 2, x minus 2.
And how about the x squared plus 3x plus 2?
Plus 2,
X plus 2, x plus 1. And how about the x squared minus 2x minus 3? X. Yep, exactly. Okay, now I'm going to just cross stuff off in yellow because yellow is light color. Does the x minus 2 cancel? Yep. Does the x minus 3 cancel? Yep. How about the x plus 2? How about the x plus 1? Okay, now think before you answer this question. You have something divided by itself. That's the kind of canceling that's going on here, right? That cancels out to 1 or cancels out to 0? Cancels out to 1. What do you think the most common mistake was on the test you took the first time? People said 0, right? Okay. What happens when there's division? The second one reciprocates. So let's just do that and factor at the same time. So what's the greatest common factor of the numerator of the first term? Great, so 2x times x minus 3 over what I think is x plus 9 squared. Does that make sense? Okay. And then when you reciprocate, this becomes multiplication. So the 9x plus 81 is now in the numerator. Does that have, can that factor? Look, 9, okay. X plus 9. How about the x squared minus 9? X plus 3x minus 3. Awesome. Okay. So does the 2x cancel? No. Does the x minus 3 cancel? Yes. Does the x plus 9 cancel? One of them does, exactly. So I've got 2x times 9 in my numerator over x plus 9 times x plus 3. You don't have to multiply those back together. It's okay to leave them in factored form. What is 2x times 9 going to give you? 18x. Great. Awesome. Okay. when you see this, what is the first thing that you think of doing? Common denominator, that's what I would suspect. So get a common denominator up here and a common denominator down there. They could be different. In this one, they happen to be the same thing. But it's you can treat the numerator as its own thing and the denominator as its own thing. So if you do that, what do you multiply the 1 by? So that becomes x squared over x squared. What does the 2 over x get multiplied by? So minus 2x over x squared. Does the last term need to be multiplied by anything? Nope. We are on the one that says notes on examples number 6, just in case. I think it's page 2. Yep, bottom page 3. Okay, so in the denominator, you're going to have x squared over x squared again, minus 4x over x squared, minus 5 over x squared. So that's the same thing as x squared minus 2x minus 15 over x squared, all that divided by x squared minus 4x minus 5 over x squared. Does it make sense that those x words are going to cancel? Technically, you could reciprocate this to the denominator, right? And then the x squareds would cancel as well, or you could multiply by x squared, but the kicker is the x squareds cancel. And now all you have is x squared minus 2x minus 15 over x squared minus 4x minus 5. You should always ask yourself, could I simplify this more? Like, could I factor and cancel some more? How does the numerator factor? I think it's oh, you cannot cancel the x squareds. That's killing a kitten.
Yeah.
Don't kill any kittens. Remember that stupid meme I had? Yeah, okay, so it was memorable. X minus 5, x plus 3 over x minus 5, x. So you get x plus 3 over x plus 1. So the reason that those x's don't cancel, if that was true, you could prove crazy stuff. Like, let's see, 2 plus 1 over. Now we're not going to go there. Not yet, not today. So, okay. All right, solving equations. So I think, all right, no, this one was tricky. All right, so what is the first thing you think you should do when you see this? Common denominator, spectacular. And you're almost all the way there because just the 1 needs a common denominator, right? So that's x minus 2 over x minus 2 minus x minus 3 over x minus 2 equals 2x minus 3 over x minus 2. So here's one thing that was already a bit tricky. Do you see how there's a minus sign in front of that fraction? Even though the parentheses haven't been written there really are implied parentheses. Like that fraction bar acts like a parenthesis set around that numerator. So just be aware of that. And now at this stage, you could multiply by x minus 2, and what happens to every single denominator? They cancel, they're gone. So you got x minus 2 minus parenthesis, x minus 3 equals 2x minus 3. So that's x minus 2 minus x plus 3 equals 2x minus 3.
In the beginning, you just multiplied x minus 2 over x minus 2 times just the 1.
You could have also at this stage just multiplied by x minus 2 and distributed that, and that would give you the same result.
Oh, okay.
Yep, that's the same thing. It's just not necessarily a trick everybody would come up with on the first fly, so I kind of want to go with what your intuition is so you see it that way as opposed to remembering tricks. But that definitely works. Yeah. Okay, so what happens to the x's on the left-hand side of the equation? I think they go away. I think you get, on the left-hand side, I think you now have a 1, right? So 4 equals 2x, x equals 2. And most of you got this. And I'm saying be careful. Why am I saying be careful? X equals 2 can't be the answer. Does that make sense why x equals -2 can't be the answer? It makes a 0 in the original equation's denominator. So since the only answer you found is 2 and 2 is not a possibility, what does that mean is true here? There's no solution. So a lot of you were able to do the solving correctly, you just missed the little thing that was no solution. And I think what I suggested when we first learned this is when you first start solving a problem that has a restriction at the top, write down x cannot equal 2. Does that make sense? If you do that right away when you're just first solving it, you might remember at the end once you've done all that work. But I must say that I'm sure that when I was your guys' age and in a class like this, that would have gotten me too. It's tricky. Okay, we did a gazillion of these. This is gonna be on your final, like I promise. You need to figure this out. So solve this equation for y. We also did this when we talked about inverse functions. It's just that then we switch the x's and y's and solve for y, added that one extra step. So the first thing that you can do is multiply by 2y plus 1. Does that make sense? So you'll have x times 2y plus 1 equals 4y plus 5. Does that make sense why that's true? Okay. Now, what's the thing you're going to do next? Say that again? Minus x. You can't minus x, though, because x is multiplied here.
Sorry,
Distribute, yep. What do you, so, yeah, you definitely distribute. 2xy plus 1 equals 4y plus 5. So what were you going to divide by? It's plus x, yes it is. I was just testing you. Okay. Now, this is where the bit of a trick comes in, and the trick is to get the y's on the same side. That's the trick. You have to kind of understand that this thing is an option. So you'll have 2xy minus 4y equals 5 minus x. Do you see what I did there? The 4y goes over there, the x goes over there. And this is helpful because then, on the left, you have a greatest common factor. And what is it? Yes, it is. But we're just solving for y, so let's just pull out the y. I didn't realize that there was even a 2. I was just thinking about the y. And now how do you get the y by itself? By 2x minus 4. So your answer is 5 minus x over 2x minus 4. But that whole idea that you get all the terms that have the thing you want to solve for on the same side comes up in calculus, and I can even tell you it comes up in section 3.5 implicit differentiation. I can tell you where it is. It's a little bit different because you're solving for a different thing, but the strategy is get all those things in the same side, factor them out, and then divide. It's the same kind of idea. Okay, inequalities are not exactly like equations. They're a little bit different. So we'll talk more about this explicitly on the one we're going to do tomorrow, but you solve them more or less like equations if they're linear, meaning like you don't have a squared in there at all. So for this one, you get 30 minus 12k is bigger than or equal to 6 minus 8k. What was the only difference when you're solving a linear inequality versus an equation? What's the one thing that flips stuff around? If you divide by a negative, you flip the sign. It's the one thing that's a little bit different, right? So I am going to take away 30. So minus 12k is bigger than or equal to minus 24 minus 8k. Then if I add 8k, I get negative 4k. Bigger than or equal to minus 24. and k is less than or equal to 6, right? So that's inequality. What does it look like in a picture? At 6, filled in circle, and which numbers are less than 6, on the left or on the right of 6?
5.
Left of 6. Which as an interval is minus infinity up to 6 with a square bracket. I care much more about those two than the picture, but the picture helps you get the interval. Yes?
Could you have done it the other way?
Mm-hmm. The other way, you would have ended up with 6 is bigger than or equal to k. And by the other way, I think, what do you mean by the other way?
Well, that's what I was thinking, but maybe I'm doing my math wrong, but like,
Uh-huh.
I'm not getting it right.
You didn't get 6?
No, I got 6.
Okay, you did some addition wrong or something like that in that point. But yes, you could totally have done the other way. By which I think, Natalie, means you could have added 12k instead, which would have meant that you wouldn't have had the whole dividing by a negative business. Okay, so yeah, that's totally fine. All right, absolute value inequalities. Whoa, those absolute value bars do definitely change things. So here's my strategy. Think about a simpler one. Think about like absolute value of x less than 5. So think about what numbers, when I absolute value them, are less than 5. So obviously the number is less than 5, right? But the problem is you can't go too low. How low is too low? -5. So you see how this, with an absolute value, is the same as that.
Wouldn't that have to be 0 because you can't go lower than 0 is negative?
Think about the solutions to this are the numbers that work. Does that make sense? They're the numbers that when you plug them in, you get a true statement. So
So you plug in -5, it's still not less than 5.
yeah, exactly. But like when you plugged in -4 is okay, right? And if I put or equal to's on there, we would just have or equals to here, right? Okay, so versus, what if you'd had the absolute value of x was bigger than 5, okay? So obviously all the numbers that are bigger than 5 work, right? Would numbers like -4 work? -5 almost works. What about -6? So, or x is less than -5. So how I reason through this is I think about a simple one and I see, like I test what numbers work. And so then if I want to solve a more complicated one like this, I kind of generalize the pattern. So you see how for this one, the inequality is facing the number, right? That's more like this first one, isn't it? Which means the thing inside your absolute values, that 3x minus 10, had to be between 5 and -5. It's a sandwich between those two numbers. And if the inequality would have gone the other way, I would have used this, but I would have used 3x minus 10. And then it's pretty easy to solve once you know that's what it translates into. So you add 10 to everywhere, and you get 5 less than 3x less than 15. And so what is x stuck in between? 5/3 and 5. Okay, so those are definitely, like, absolute value inequalities are definitely tricky. I totally get that. Okay, and then came the onslaught of solving a whole bunch of equations. How about you give this one a try, because it really is like Algebra 1, and I think you can do it. Distribute the negatives very carefully. once you got it, check and see if you got the same answer as me. You should leave your answer as a fraction, not as a decimal, because your test is going to be no calculator for the most part. Everybody get 26/15ths? Got weirdness? Okay. Your steps might look different in the middle depending on what you added and subtracted and how you combine stuff, but as long as you arrive at 26/15ths in the end, you're fine. Okay. Whew. How about the one with absolute value bars? That's next. So reduce it to the simple thing again. Absolute value of x equals 17. Is there only one number that makes that work, or are there more than one numbers that makes that work? 17 works. What else works? Negative 17. So here, same idea. 2x minus 1 could have been 17, and 2x minus 1 could have been negative 17. And then you have to solve both equations individually. So, yes?
This is the one that you had said before, we just changed the sign of the answer.
I definitely did not say that.
We changed I know there was a pattern that we did.
Oh, there's definitely a pattern, is that the sign of whatever you're equal to changes.
Okay.
But this is the reason, right? I think it really helps to think about what if it was a really simple case, and then how does that simple thing, it's kind of like substitution. We kind of did that with factoring. We said, okay, let u equal whatever, right? It's the same kind of idea. Simple thing, make it work for harder stuff. And there are two answers. Notice that they're not the exact opposites of each other, right? How could you check and see that they worked? Just plug them into the equation. Yep. So, and when you plug in 9, you're going to get 17 in the absolute value bars. When you plug in negative 8, you're going to get negative 17 in the absolute value bars, which then absolute value is 2, 17. Okay, what was the most common mistake on this one? Students did this, divided by x. Why is that a problem?
X could be 0.
X could be 0. And the whole, which means you can't divide by 0, right? So it's a possibility, don't divide by it. This also came up in the chapter 3 to 5 test, because you divided by x in an inequality. And in those inequalities, x could have been a negative number, which flipped the sign. And if you did that, you got the question completely, totally wrong. So don't divide by variables, if you can avoid it, okay? Instead, let's just get everything on the same side of the equals. So 2x squared minus 4x. And actually, can you tell just from looking at the question that 0 actually is an answer? You can, right? So if you can see that, just say, oh my gosh, x equals 0, I know it. If you're at this stage, take out the greatest common factor. And so one answer, 2x equals 0, that tells you x has to be 0, right? The other, x minus 2 equals 0, tells you x has to equal 2. Okay. Wholly factoring. So 2x squared minus 7x plus 3 equals 0. I think it's good you know how to guess and check, so we're going to try. So 2x squared is 2x and x. I'm going to write two options here. You tell me which one's right. Either it's plus 3 plus 1, or it's plus 1 plus 3. So before you tell me which one it is,
Minus 3 and minus 5.
oh, it's neither of them. Is it 2x minus 1, x minus 3? Is that the right one?
Yeah.
Yes. Okay, so my first ones, I failed at trying to lead you in the right direction. But the point is that this first thing plus this thing multiply to make that first thing, right? This last thing plus this times this last thing multiply to make that. So with both 2 and 3, there aren't that many options because they're prime numbers, right? And you check and see that you're right by just multiplying it together mentally, probably. All right, now solve each of them. 2x minus 1 equals 0, x minus 3 equals 0. So what do you get for the first one? X is a half. Second one, you get x equals 3. I think we did something awfully similar in in chapter 7 recently, but instead of x squared, we had sine of x squared. It was the same kind of pattern though. Because I remember solving sine x equals a half. I think that happened. Okay. So this one, you can factor out a greatest common factor, but other than that, it doesn't sort of solve, does it? So how about you take away 20? Divide by 5. Right? And then you square root. And when you square root a negative, what kind of answers do you get? You get imaginaries, right? So this is x equals plus or minus 2i. Imaginary stuff doesn't come up super often in calculus, but if anybody's interested in being an electrical engineer, they apparently use it all the time. It does come up in the context of there are no real solutions to this equation, only imaginary ones. Yes?
If on problems like that, couldn't we just leave it as the square root of -4? Or do we have to like change?
I'd like to know if that you know that the square root of -4 is this imaginary number thing. So you wouldn't get full credit, but you wouldn't be, but it would be a little bit wrong. All right. How about this one? Square root. Great, move the x over. And then what do you do to both sides to get rid of the square root sign? Square it. So 5x minus 6 equals x squared. So I'm going to put all the stuff from the left onto the right. So 0 equals x squared minus 5x plus 6. Man, that thing came up a bunch of times in this test. X minus 2, x minus 3. So what are your answers? And this is a bit tricky here. Whenever you're solving equations where you square both sides, there are numbers that work in the second one but don't work in the first one, because this thing became positive when this could have been negative. And so you do have to actually check these. Now they might both work, one of them might work, it's just a matter of plugging them in. It shouldn't be super challenging. So you get root 10 minus 6 minus 2 equals 0. Does that work out? Yep, so that one works. You get root 15 minus 6 minus 3 equals 0. Does that one work? Yeah, okay, so they do both work, but that's not always the case. Okay. What do we got next? Oh my goodness, more equations. All right, crazy factoring. M to the 4th plus 5m squared minus 36. How is this similar to a regular factoring thing? You can do a substitution, so like you could let, say, u equal m squared. You don't have to do this if you can sort of figure this out without that. So this would become u squared plus 5u minus 36. Does that make sense? Which then is now reduced to something that you can actually handle, right? I think that's u plus 9, u minus 4. Is that right? And then plug back in what u is. U is m squared. And I think some of you were pretty much able to go from the original problem to that first step, this step that I'm at right now. Is that true? And if you can do that, that's fine, okay? Like, if you can do this without substituting, it's totally okay. I'm not going to be mad at you for being faster than me. And now at this stage, you solve m squared plus 9 equal to 0 and solve m squared minus 4 equal to 0. So the first one, m squared equals negative 9. So what's the m? Plus or minus 3i. This one you got m squared equals 4, so m will equal plus or minus 2. I don't like taking off points when you forget the plus minus, but I have to, so don't make me do it. Please don't forget it. Because you miss half of the answers if you do. Does that make sense? Okay, awesome. How about this B? Yes?
So, when, I mean, the last one you checked, so are we not, I guess you can't with me that one.
You actually, Eve, you can check it even with I. It's just, it's gonna take so long, and I just know a bit, I know when I have to check and when I don't, and you definitely have to check when you take an equation and you square it. But when you square root it, you don't have to. It's, ask me later, it's a bit tricky. But I just don't want you to waste your time checking all of them, especially if they're I's, they're just complicated to check. All right, how is this one? What would your substitution be? X to the third, because then u squared is x to the 2/3, right? So that's u squared minus 5u plus 4 equal to 0. So that's what, u minus 4, u minus 1? Or x to the 1/3 minus 4, x to the 1/3 minus 1. So you have x to the 1/3 minus 4 equals 0, and x to the 1/3 minus 1 equals 0. So x to the 1/3 is 4. How do you get x from that?
Cube it.
You cube it. So x is 4 cubed. And what is 4 cubed? 64. X to the 1/3 equals 1. In that case, you cube 1 and you just get 1. Okay. Do you remember how to complete the square? I think that the most important application of completing the square probably is in making parabolas easy to graph. That's probably how it's going to show up. This is the first place we saw this idea. It lets you solve equations that you can't solve by factoring. Does that make sense? Like no numbers multiply to make 13 and add to -6. Does that make sense? Okay, so what was the first step you did when you completed the square? I moved the 13 over, but you don't have to do it if you want to. So then you add a number to both sides, and what is the pattern? Half squared, exactly. So half of -6 is -3, squared makes, the number you will add will always be positive because you're squaring it, right? So the fact that that's a negative doesn't matter at all. And if you add 9 to that side, you add 9 to that side too, right? And so then this factors into x minus 3 squared equals -4. And the reason this is helpful is this now allows you to use square roots to solve, right? So x minus 3 will be plus or minus the square root of -4, which is, so x minus 3 equals plus or minus 2i. And the answers are often written like this, as 3 plus or minus 2i. It's not wrong if you write plus or minus 2i plus 3. It's the same thing. Addition is commutative and you can change the order. It's just, it's less things to write if you do it that way. There's one less symbol there. Okay. What was the other option for solving a quadratic equation if factoring fails? Which is x equals -b plus or minus the square root of all over 2a. And if you really feel like it, there's like probably a YouTube thing to Pop Goes the Weasel that sings that song if you want to have that stuck in the head for the rest of your life. I'm not going to sing for you. So what this does is it solves ax squared plus bx plus c equal to 0. Does that make sense?
Is that what we put for briefly?
That's what the briefly explain means. It solves any quadratic equation if it is equal to, which you can always make them equal to 0, but the point is it has to be equal to 0 to find what the a, b, and c are. If it's not equal to 0, you must do that first. And it always works. So if you forget how to factor, if you forget how to complete the square, this is a method that works. Like I think I told you guys that my Russian husband calls solving by factoring, factoring by staring, or solving by staring, because he's like, why don't you just use the quadratic formula? It always works. Except for factoring is faster when you see it, right? All right, and then I gave you formulas. So 2 points, find the formulas. So the distance between them and the midpoint of the line segment. So these formulas do come up in calculus. So that distance is, there's kind of a triangle there, isn't there? This side of the triangle is the difference in the x's. This side of the triangle is the difference in the y's. And who's first depends on who's bigger. Does that make sense? So, and the distance is the hypotenuse of that triangle, right? So what theorem do you think made this formula? The Pythagorean theorem. So it'd be d squared equals x2 minus x1 squared plus y2 minus y1 squared, right? So then the distance is the square root of that stuff.
And this is a formula we have to memorize.
You have to memorize this one, yes. And I'll probably put it on your final because it does definitely come up in calculus. It is easy points, and it is the Pythagorean theorem. It's not very hard to think about why it's true, yeah.
Now, in every textbook assignment, lesson I've ever seen, it's always x2 minus x1 and y2 minus y1, but you...
It doesn't it doesn't matter, yep.
Were you talking any points for that?
Oh God, no, 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 no.
Thank you.
It is totally fine if you write x1 minus x2 plus y1 minus y2. I will not dock you points for that because they're equivalent. And the thing is like, if y2 minus y1 were positive 3, y1 minus y2 is going to be negative 3, and when you square them, it's the same result. So it actually does not matter. It's kind of like the slope equation, which is y2 minus y1 over x2 minus x1. Does the order matter there? It doesn't matter there either. As long as if you flip the numerator's order, the denominator's order flips too. But in this one, you can also not flip them and it's still the same. Doesn't matter either way. How about the midpoint, the halfway point? Halfway kind of is an average, right? So my intuition says you have an x and a y, right? If you want to find the halfway point between them, you find the halfway x, you find the halfway y. Does that make sense? So the halfway x is add the x's, divide by 2. The halfway for the y is add the y's. And that's the point that's in the middle. And that point will actually be on this line, and proving that requires a little bit of work. You actually use the distance formula. But I think the intuition that, oh my gosh, the middle probably is find the middle of the x's and the middle of the y's works out. Okay, circles, yay. So circles are all of the points that are the same distance, all of the points that are a fixed distance from a center, right? Now the equation for a general circle was x minus h squared plus y minus k squared equals r squared. That came from that distance formula thing. And h comma k, those are the coordinates of your center. Okay. So when you plug in the center, you get x plus 2 squared plus y squared equals what? 25, or 5 squared. If you left it as 5 squared, I'm not unhappy. that's part A, give the equation. Part B is to write the equation in standard form and then find the center and the radius. So this is an application, the first one we saw, of completing the square. Another one. You see how you notice how you have x plus something squared, y plus something squared, right? You go back to that by completing the square. So you've got x squared plus 2x plus y squared. And that's gonna, I think this, I'm gonna go out on a limb. I think that's supposed to say 10y. I think I actually made a typo and didn't catch it until I started grading tests. So let's change that to 10y. I actually had to grade the test both ways because some of you realized it was typo and you put a y there, and some of you didn't. I mean, obviously, because it isn't obvious, move the 10 over with the 55, which was totally correct. So now you complete the square for each variable. So what number gets added here? 1, great, because it's half of 2 squared. And if you add 1 to the left side of the equation, add 1 to the right side, be fair. Okay, what's half of 10? 5, and 5 squared is? So if you add 25 to the left side, you add it to the right side, correct? And then you factor each variable as a group. How does the x squared plus 2x plus 1 factor? Squared plus y plus 5 squared equals, great. So then where's the center for that circle? Where's the radius? 9. Great. Okay. We good? Okay. Alrighty. So y plus 2 over x plus 3 equals 1. So this actually is a line. It's just you have to get it into y equals mx plus b form. So how about we first take away the x over 3? So y over 2 equals negative x over 3 plus 1. How might you get the y by itself after doing that? Times by 2. So that's y equals negative 2 over 3x plus 2. And now that you've made it into that form, can you graph the line? Where do you start?
2.
On the x or y axis? Y, okay. And from there you go and forwards 3. Down to forwards 3. What you can think about is if that slope is negative, as you look at this picture from left to right, you're going downhill. If it were a positive number, you'd be going uphill. What does the line x equals 3 look like? Is it vertical or horizontal? Vertical. Okay, great. Ooh, next page. All right, write an equation of the line that contains the indicated points and has the given slope or intercepts. Okay, so first thing, given 2 points, find the slope. What is the slope formula? Great. So that'll be 5 plus 1 over 10 minus 2. So in this case, the m is 6 over 8. Is that right? Which is 3/4. Do you guys agree with that? Yeah, okay. So then I choose to use point slope form. That's my favorite, and your teachers are going to use that in calc, so it's good to get used to it. Y minus y1 equals m times x minus x1. It's just the slope equation with the x's multiplied over. Instead of x2 and y2, you have y and x. So plug in whichever numbers you want. I'm plugging in the first ones. y plus 1 equals 3/4 x minus 2. So y plus 1 is 3/4 x minus 6/4, right? Which is the same thing as 3/2, right? So y plus 1 equals 3/4 x minus 3/2. What happens when you take away that 1? What is negative 3/2 minus 1? Say that again? Minus 5/2, yep. Okay, how about part B? So let's find the slope, see what happens. We got 0 minus 6/2 minus 2. Negative 6/0, right? That's undefined. Everybody agree? So as a picture, is that a vertical line or is it a horizontal line? Is where you gotta think a little bit. It's a vertical line, right? And then if you just like sort of graph these points, the points are over 2, up 6, over 2, up nothing. So obviously, what is the vertical line through them? X equals 2. And most of you on that problem got that the slope was undefined, but you failed to realize that undefined things make, it's okay, just close the door.
Okay.
Not a problem. That's a vertical line, okay? All right, I think we can finish example 8. At least we can start it. Yeah.
Sorry,
Well, when you have an undefined slope, that is a vertical line. Like the slope of vertical lines is undefined. That's what they are. And so then what you can do to figure out which vertical lines are x equals something, is you can just graph these points and say, okay, the line through them goes through x equals 2.
would you ever have like a horizontal?
If you had a horizontal line, what would the slope be? The slope would be 0.
Okay.
Yep. So yeah, it is possible. That'd be if the y's were the same versus in this one the x's are the same. Okay, so I'm just going to start example 8. It's awfully similar to the previous ones. The only tricky thing is finding the slope. So we have this line. We want to find the equation of lines that are parallel to it and perpendicular to it. So this is the same thing as 5y equals negative 4x plus 10, right? So y equals negative 4/5 x plus 2. Do you guys agree with that? Okay. If your line is parallel to that line, what is the slope of your line? Same thing, negative 4/5. If your line is perpendicular to that line, what is the slope of your line? 5/4. And then you use that and the point 24, because that's the point you were given, to get the equation of your line. Y minus y1 equals mx minus x1. So the first one is y minus 4 equals negative 4/5 x minus 20. Just get the y by itself there. Second one is y minus 4 equals 5/4 x minus 20. And I was kind of nice because I made a problem where 4/5 times 20 works out well, and 5/4 times 20 also works out well. Is that all right? Okay. I do realize that with this